Hello students, today we are covering lesson 4.1 on writing and graphing inequalities, so follow along in your textbook on page 126, please. Our key ideas need to be written down in your notes, so make sure you write down the vocabulary and the chart that you see here. It says an inequality is a mathematical sentence in which we compare two expressions. And when we have inequalities, there are four symbols that you will see. The first symbol here is less than, and the key phrases will be is less than or is fewer than. The second symbol is greater than, which can also be seen as more than. The third symbol is less than or equal to. Other times you might see is at most or is no more than. And the fourth symbol is greater than or equal to, is at least, or is no less than. So pause the video and take a moment to copy this down, please. Example 1 is on writing an inequality. A number q plus 5 is greater than or equal to negative 7.9. Write this word sentence as an inequality. So I'm going to just highlight a few of the key pieces of information. Q plus 5. That's our first clue. So I'm going to rewrite it simply as Q plus 5. Is greater than or equal to. So in that whole phrase, this is greater than or equal to negative 7.9. So all you have to do is translate word for word and change the word phrases into mathematical expressions. Okay, so you have Q plus 5 is greater than or equal to negative 7.9, and that's all you have to do. Go ahead and try on your own numbers 1 and 2 on page 126. A number x is at most negative 10. Refer to the chart for that one. Twice a number y is more than negative 5 over 2. Pause the video to complete these problems. Now we have another key idea, and I would also like you to write this down. It says a solution of an inequality. Now, when we have inequalities, we need to know what values will work. A solution is a value that makes the inequality true, a true statement. The solution set is a set of all possible numbers that will make the inequality true. So I'm going to do 3 examples with you. Here I have a chart for the values of x. And I have this expression, x plus 2 is less than or equal to negative 1. Well, let's pretend x is negative 2. Negative 2 plus 2 is less than or equal to negative 1. Well, negative 2 plus 2 is 0. Is 0 less than or equal to negative 1? No. 0 is not less than negative 1. It is greater than negative 1 because it's further to the right on the number line. Now let's try negative 3. Negative 3 plus 2 is negative 1. Is negative 1 less than or equal to negative 1? Well, since they're equal, yes, it is a true statement. And the fourth one, or the third one, negative 4 plus 2 is negative 2. Negative 2 is less than negative 1. Since it's less than or equal to negative 1, yes, it is a true statement. So now I can see that negative 3 and negative 4 are part of the solution set because it makes the inequality true. Whereas negative 2 is not part of the solution set because it is not true. Okay, so example 2, now we're going to check solutions. Tell whether negative 2 is a solution of each inequality. So instead of y, I'm going to substitute it with negative 2. negative 2 minus 5 has to be greater than or equal to negative 6. Well, since they have the same sign, I add and keep, so this is negative 7 is greater than or equal to negative 6. Well, if you look on the number line, here's negative 7, here's negative 6, negative 5. In order for it to be greater than or equal to negative 6, it has to be to the right, and negative 7 is not there. So, no, this is not a solution. On B, it says negative 5.5y, which is negative 5.5 times y, which is times negative 2, has to be less than 14. So I'm going to multiply 5.5 times 2, which is 10. Regroup, that's 11. A negative times a negative makes a positive. Is 11 less than 14? Yes. If you're not sure, always draw a number line to double check. Okay, here's 14. It has to be less than 14. Yes, 11 is less than that. So it is a true statement. Now try on your own numbers 3 through 5. Pause the video and test whether negative 5 is a solution in these three expressions. Now example 3 is about graphing inequalities. We have y is greater than negative 8. Now when we graph an inequality, you need to know two things. The open circle is for greater than or less than. The closed circle on the number line when we graph is for greater than or equal to, less than or equal to. This is used when it is equal to a number. This is used if it's just more or less. So here you can see that y is greater than negative 8, but not equal to it. So we're going to be using the open circle here. Now we find negative 8 on the number line, which is right here. And we know y has to be greater than that amount. So when we graph the inequality, we need to go to the right. So I'm going to put an open circle at negative 8, and I'm going to graph all the way on the number 9, not above it, not below it, but actually on the line. And I like to make the line slightly thicker just so you can see it clearly. And so any solution greater than negative 8 will be true for y. At this time, I would like you to try graphing 6, 7, 8, and 9 on a number line. This is on page 127 in your book. Pause the video to complete these problems. Now your exit ticket is to decide whether a number is a solution of the inequality. How do you decide? What should you do? Look back at example, let me check here. Look back after example 1 at the chart when we have a solution to an inequality in the solution set. That key idea will help you answer this exit ticket. I hope you have a great day, and I will see you in class tomorrow. Bye-bye.